In this problem, we're asked to find RL for maximum power transfer and the maximum power transferred. And you can see the circuit there. Now we're going to utilize the problem solving strategy for entitled Applying Thevenin's Theorem, and that's because we need to calculate the Thevenin equivalent. So what we're going to do is we're going to remove RL from the circuit. We're going to calculate the Thevenin equivalent for the rest of the circuit. If you remember, a Thevenin equivalent is an open circuit voltage in series with a Thevenin resistance. We'll connect RL, and we know for maximum power transfer that RL is set equal to R Thevenin for maximum power transfer. So now let's take our circuit, let's remove RL, and then let's calculate the Thevenin equivalent circuit as the first step. So we move RL from the circuit. Here is our circuit, and if we look for a moment, this current's 0, so the voltage across this resistor is 0. Now, we basically have a single loop circuit, and if we apply Kirchhoff's voltage law around this loop, VOC is going to be equal to the voltage across the 12K resistor. Well, let's call that voltage V1, and let's calculate V1 using voltage division. That's because we got a voltage source and two resistors in series. So V1 is 6 times 12K over 12K plus 6K. So that tells me that V1 is equal to 4 volts. And if we apply KVL around here, around this loop, VOC equals V1 equals 4 volts. Now, we need to find the Thevenin resistance, and since we have only an independent source, we'll turn it to 0. And we do that, that becomes, in essence, a short circuit. So here is our circuit for calculating our Thevenin. See, that's where the voltage source was. We turned it down to 0. So our Thevenin then, we have these two resistors in parallel in series with a 2K. So our Thevenin then is 6 kiloohms. So our Thevenin equivalent circuit then is a 4 volt source, a 6 kiloohm resistor. Now we're going to hook up our resistance RL. For maximum power transfer, RL equals 6 kiloohms. Okay, so for maximum power transfer, RL should be set equal to R Thevenin. Now to calculate that maximum power, let's use voltage division. And since we have two equal resistors, the voltage across RL is 2 volts. So there's 2 volts across this resistor, 2 volts across this resistor. So then the maximum power transferred is 2 squared divided by 6K, which is 2/3 of a milliwatt.